Hi guys, this is 10B notes, and in this video I will go over examples number 6 and number 7. And again, here we have similar problems to what we were doing with examples 4 and 5. We're asked to find x, the length of the missing side. So of course, where we're going to start, we're going to always start with our SOHCAHTOA. You should have this memorized. SOHCAHTOA. Now, of course, I could provide this to you, but I want you to be able to remember this for ACT for next year. I want you to take this with you. And so for each time you're trying with these trig problems, go ahead and write down your SOHCAHTOA. And then we really want to be clear on what we're looking for. We're looking for x. And then, of course, we want to label our triangle. This long side opposite from our 45 or our 90 degree angle, rather, is we always label with a capital H. That is our hypotenuse. That is always the hypotenuse. It doesn't matter which angle we're looking at. But now we want to really identify what angle we're interested in. And it had been that we were seeing this as a theta. Now we have a value, but that is still the angle we want to label our legs with respect to. And so this side here that's touching it or next to that angle, we label with a capital A for adjacent, meaning next to. This side all the way across, not touching our angle, we label with an O for opposite side. So adjacent side and opposite side. Now we want to look at what information we have. We have information, a variable for our adjacent side and an actual side length for the opposite side. We don't have anything on the hypotenuse, so let's look for a trig identity that is just needing adjacent and opposite. So of course that is our tangent trig identity, which is tan of theta, or some angle, equals the opposite side over the adjacent side. And now we'll do just what we did in example 4 and 5. We'll plug in to our trig identity. When we're doing that, we want to fill in the measure of our angle. It's still 10. Now, though, we have a value for it, 37 degrees. The measure of the opposite side is 20. The adjacent side is what we don't know yet and has a variable x. We'll go over to Desmos and we'll find out what the value of the tan of 37 degrees is. Again, you want to be sure in your settings up here where the wrench is that you're in degree mode. And then in your functions, you'll press your tan button and fill in 37 for the degrees. Now, we always want our answer in two decimals, 2 places past the decimal. The third place is a 3, so 4 or less, we'll let it be that second spot. So our answer for the tan of 37, or the tangent of 37, is 0.75. Okay? 0.75. Now that is still equal to 20 over x. Here's where a lot of students get frustrated. The x is now on the bottom. What are we going to do? Well, the way to get your x out of the bottom is just like we would do anything else. Since it's on the bottom, we're going to just multiply by that x. Both sides. Up x, down x, that'll cancel. And it'll leave us with this x times 0.75, which we like to usually put it in front of our x. And that will equal 20. So remember, if x is on the bottom, not to worry, just multiply both sides by x. Now we want to solve for x, and so we're going to divide both sides by that 0.75, because here x is being multiplied by the 0.75, and we're always looking to do the opposite operation there. And of course, always to both sides. We'll divide both sides by 0.75, and that will give us what we want, x by itself. Now, what's 20 divided by 0.75? Well, you're just going to go into your calculator and take 20 and divide it by 0.75. And our answer, again, we want to give to two places past the decimal. Since the third place is a 6, 5 or above, we'll round that second spot up, 26.67. So our value of x and our missing side length, 26.67. The next example is example number 7. We'll do it just like we did example number 6. So for example number 7, of course, we want to do that SOHCAHTOA like we always do. And we already have done that for our first example. But we'll just go ahead and do it again so that it's over on this side of the whiteboard. SOHCAHTOA. Okay? Now the next thing we want to do, we want to make sure we're clear on what we're looking for. We're looking for x. It's a side length. And then we want to label our sides, always starting with that hypotenuse directly opposite our 90-degree angle, labeled with a capital H for hypotenuse. Now we're just making sure that we understand what our angle is. Here's our angle. It's not a theta anymore. We've got value, but we still label those legs with respect to that angle. The side touching the angle, that's our adjacent side. Adjacent meaning next to. All the way across the triangle, not touching the angle, we label with a capital O for opposite. So let's look at what information we have. Nothing for our hypotenuse. Once again, just for the adjacent and opposite side. So our tan is our trig identity to go with once again. Tan of theta, our trig identity, is equal to the opposite side over the adjacent side. We'll go ahead and plug our numbers in now. The tan of theta, instead of theta, we've got a value for that angle. It's 41 degrees, and it's equal to the opposite side, which is 4. Over the adjacent side, there's x. Now, what I want you to see is that you have two examples that are essentially the exact same examples. Oops, got our red going again. And the reason why I'm giving you two examples like this is because of the fact that so many students are thrown off by that x on the bottom. See, that's exactly what we had over here, is the x on the bottom. And it's a simple fix, but a lot of students get hung up with this x on the bottom. So let's just review once again what we're going to do when our x is on the bottom. We're going to multiply both sides by x. And when you multiply a fraction, 4 over x, you're going to multiply it by x over 1. Now here we just multiply both sides by x. You don't have to write the over 1, all right? But if it helps you to see that when you multiply by x, that x is on top, feel free to put it over 1 if that's helpful. Now, just like we've seen before, x on top cancels with x on bottom. Okay? Once more. Okay? X on top cancels with that x on bottom. And that's because we'll end up 4 times x over x times 1 will end up being 4x over x. And we know that x divided by x is just 1. And we'll just end up with 4 anyway. Okay? That's how come the top and the bottom cancel. Because they divide out to 1. So we'll end up with tan of 41 times x equals 4. Now, we did this one a little bit different. I'm just wanting you guys to see that you can find your value for tan in the beginning, or you can do it here. It really doesn't matter. So we'll go ahead and go into Desmos and find out what the tan of 41 degrees equals. The tan of 41 degrees is going to give us 0.87 because that third spot is a 9, so we'll round up. .87. X, we're still multiplying by x, equals 4. Now, in order to solve for x, we want to ask ourselves, what's being done to x? Well, it's being multiplied. When you see some number next to a variable, and there's no plus or minus in between, you know that that's multiplication. So we're going to do the opposite operation, and we'll divide now. Divide by 0.87, and we'll do that to both sides. Up 0.87 will cancel with down 0.87. Need a little bit more whiteboard. And now we've got, since this is canceled, we'll see that x is equal to 4 divided by 0.87. So pop over to your calculator. 4 divided by 0.87. That's going to give us 4.597. But because the 7 is 5 or above, we're going to round this up and end up with 4.60, because that 9, that doesn't have anywhere to go. That's going to have to go to a 0 and bump that 5 to a 6. 4.60 is what we'll end up with. X equals 4.60. And that is the length of our missing, that's the length of this missing side, 4.60. That's our X. All right, guys, thanks for watching.